Class 12th Chemistry, Haloalkanes and Haloarenes, and in this video we will discuss about nature of carbon halogen bond and methods of preparation of haloalkanes and haloarenes. First of all, nature of carbon halogen bond. Halogen atoms are more electronegative than carbon. Therefore, carbon halogen bond of alkyl halide is polarized. The carbon atom bears a partial positive charge, whereas the halogen atom bears a partial negative charge. We can represent this bond like this. The shared pair of electron is more close to this halogen. That's why partial negative charge and partial positive charge on carbon appear. Carbon halogen bond length increases from CF to Ci. Why? Because size of halogen increases from fluorine to iodine. Methods of preparation of haloalkanes. First method is from alcohols. ROH converting into RX, and in this case this OH is replaced by halogen, and there are number of reagents which are used for this reaction like concentrated halogen acids HX, phosphorus halides PX3 or PX5, or thionyl chloride, that is SOCl2. See, this alcohol when react with the HCl in the presence of ZnCl2, this OH is replaced by Cl and we will get RCl plus H2. The reactions of primary and secondary alcohols with HCl require catalyst zinc chloride. With tertiary alcohols, by simple shaking with concentrated HCl at room temperature is sufficient to give the product. Okay. Constant boiling with HBr, 48% of HBr we are using, is used for preparing alkyl bromide. And there is another method to prepare the alkyl bromide by using NaBr and H2SO4 with alcohol. Actually, in this reaction, first of all, this NaBr and H2SO4 react and they produce HBr. That HBr react with the ROH and OH is replaced by Br. Ri, that is alkyl iodide, may be obtained by heating alcohols with sodium or potassium iodide in 95% orthophosphoric acid. The order of reactivity of alcohols with HX is tertiary alcohols are most reactive and primary alcohols are least reactive with HX. Okay. Alkyl halide can also be prepared by using phosphorus trichloride and phosphorus pentachloride. Reaction is like this. 3 molecule of ROH when react with the PX3, OH is replaced by X and we will get RX plus H3PO3. In this case, this X may be Cl or Br. OH may also be replaced by Cl using phosphorus pentachloride, and products are RCl, POCl3 and HCl. PBr3 and PI3 are usually generated in C2. Now, what is the meaning of this C2? That is produced in reaction mixture by the action of red phosphorus with Br2 and I2 respectively. This can be represented like this. Alcohol converting into RX, where X is Br and I. We are using the red phosphorus with Br2 or I2. Okay. Then this alcohol also react with the thionyl chloride to produce RCl, SO2 and HCl. Actually, this reaction, that is reaction with thionyl chloride, is preferred. Why? Because in this reaction, alkyl halide is formed along with the gaseous SO2 and HCl, which are escapable. Actually, these are in the gaseous form. That's why they remove from the reaction mixture and we will get the pure alkyl halides. These methods are not applicable for the preparation of aryl halides. because the carbon oxygen bond in phenols has a partial double bond character due to resonance and is difficult to break. We can see like this. This is the phenol. Okay, and when this phenol, this is the OH, when this react with the HCl or HBr or HX, then we will not get any product, because in this case this bond between this carbon and oxygen has to be break, but due to the resonance this has some partial double bond character which is difficult to break. Next method is from hydrocarbons. From alkanes by free radical halogenation. In 11th standard we have discussed, when alkane react with the halogen, especially in presence of Cl2, in the presence of sunlight or heat, these hydrogen atoms can be replaced one by one and we will get these products. And the drawback of this reaction that we are getting the isomers, which is very difficult to separate. From alkenes, addition of hydrogen halides, that is HX. This is the double bond. This is the addition reaction. This is HX. The pi bond will break down, and this H is added to the one of the double bonded carbon atom, and X will go to the another double bonded carbon atom. And if we are having the unsymmetrical alkene, then products are according to Markovnikov rule. I think you remember what is this Markovnikov rule. When unsymmetrical reagent is added to the HX, the X will added to that double bonded carbon atom which bears the lesser number of hydrogen atoms. Okay, in this way we can say this is unsymmetrical alkene. When this react with the HI, this I will attach to which double bond carbon atom? To this one, because this carbon bears the lesser number of hydrogen atoms. Okay, addition of halogens to alkene. This is the reaction. This is alkene. When Br2 is added in the presence of carbon tetrachloride, again this pi bond will break, and on both the double bonded carbon atoms Br will added, and we will get the vis dibromide. And actually this reaction, that is reaction of alkene with bromine, this is used to detect the presence of unchanged duration, that is double bond. How? Discharge of reddish brown color of Br2 is used for the detection of double bond in a molecule. There is one example, 10.3. Identify all the possible monochlorostructural isomers accepted to be formed on free radical monochlorination of this CH3 twice CH2 CH3. How can we obtain? In this case, there are 4 different types of hydrogen atoms. So 4 products are possible. You can write this structure. This is CH3, this is CH, this is CH3, and then this is CH2 and CH3. If hydrogen atom from this carbon is replaced, we will get this one. Okay. If hydrogen atom from this carbon is replaced, we will get this one. And if hydrogen atom from this carbon, that is this hydrogen atom is replaced, we will get this one. Okay, and if hydrogen atom from either this methyl group or from this methyl group is replaced by Cl, then we will get this product. Okay. Now next method of preparation, halogen exchange. Alkyl iodides are often prepared by the reaction of alkyl chlorides or bromides with NaI, sodium iodide, in dry acetone, and this reaction is known as Finkelstein reaction. Dear student, whatever the name reactions which are we are going to discuss in this organic part, you have to remember these. Okay, Finkelstein reaction. This is used to prepare alkyl iodide from alkyl chloride or bromide. That is Rx, where X is Cl or Br. When react with the NaI in the presence of dry acetone, it will convert into Ri plus NaX. Now, what is the meaning of this dry acetone? Okay. Dry acetone means this is a pure acetone. It doesn't contain any amount of impurity or water. Okay. Now, what is the criteria to get the product in this reaction. Actually, sodium iodide is soluble in triacetone. Again, question arises, why this NaI is soluble in the triacetone? Because this NaI has more covalent character. Okay, according to the Fajan's rule, size of iodide ion is bigger, and that's why Na plus can polarize this. That's why more covalent characters are introduced in this, and that's why this is soluble in triacetone. While NaCl or NaBr formed is precipitated in triacetone, because NaCl and NaBr are not soluble in triacetone. So reaction proceeds in forward direction according to Lee-Chatelier principle. Okay. Next, again, halogen exchange. Now in this we will discuss the preparation of alkyl fluorides. Alkyl fluorides are prepared by heating an alkyl chloride or bromide in the presence of metallic fluoride such as AgF, Hg2F2, COF2 or SbF3, and this reaction is known as Swarts reaction. This reaction can be written, this is CH3Br plus AgF. This Br is replaced by F and we will get CH3F AgBr. Now we will discuss preparation of haloarenes. Okay, that is aromatic halides from hydrocarbons by electrophilic substitution. Okay, as we know, benzene ring is electron rich. That's why any electrophile can attack on the benzene ring and hydrogen of the benzene ring can be replaced. In this case, what happens? Arene, when react with the Cl2 or Br2, then we will get the aryl chlorides or bromides, and reaction is taking place in the presence of Lewis acid, which will act as a catalyst, and these are either iron or iron third chloride. Reaction can be written like this. This is toluene. When react with the X2 in the presence of Fe and dark. Again remember, hydrogen from this benzene ring is displaced. Okay, and that's why we will get. Now again, this is ortho para directing. Okay, CS3J ortho para directing. That's why incoming halogen will attach to this ortho position. We will get ortho halo toluene, or it may attach with this para position, and in this we will get the para halo toluene. Okay, and these ortho and para isomers can be easily separated due to large difference in their boiling points. Reaction with iodine. Reactions with iodine are reversible in nature and require the presence of an oxidizing agent like HNO3 or HiO4 to oxidize the Hi formed during iodination. Okay, in this reaction, if we use I2, then product is, one of the product is Hi. Okay, and this Hi has to be converted into I2 by using the oxidizing agent. Otherwise, this reaction will go in the backward direction. Fluoro compounds are not prepared by this method due to high reactivity of fluorine. Now preparation of haloarenes. Next method is from amines by Sandmeyer's reaction. Now again try to understand. You can identify this compound. This is aniline. Okay, aniline. C6H5NH2. In the presence of NaNO2 and HX at the low temperature, that is 273 to 278 Kelvin, we will get this one, C6H5N2X, and this compound is known as benzene diazonium halide. And this process, conversion of aniline into benzene diazonium chloride, this is called diazotization. Diazotization. Okay, and in this benzene diazonium chloride is formed. This will react with the Cu2X2, and this group is replaced by halogen. Okay, and we will get the aryl halide. Now in this case, X is Cl or Br. To prepare the iodobenzene, we use the Ki with benzene diazonium halide. Clear? Now see, this is again your textbook solved example is there. Write the products of the following reactions. These are the reactions. We have to identify the product. Now in this case, this HBr is added, and this is unsymmetrical alkene. Now addition is taking place according to Markovnikov rule. These are the double bonded carbon atoms to which Br will attach. This carbon has only one hydrogen atom and this carbon has two hydrogen atom. That's why Br will attach to this carbon atom and we will get this product. Okay. Now in the same way, this one HCl is added. Addition is according to Markovnikov rule. These are the double bonded carbon atom. Cl will attach to which carbon? Definitely this carbon, which has lesser number of hydrogen atom. That's why product is this. Now again this reaction of this with HBr, and this is in presence of peroxide. Now in the peroxide, reaction is taking place anti-Markovnikov rule. That is, this Br will, that is more electronegative part of the adding reagent will added to that carbon which bears, that double bonded carbon atom which bears more number of hydrogen atom. That's why this Br will attach to this carbon and this hydrogen will is attached to this carbon and product is this. Okay student, thank you. Subscribe my channel to watch the new videos of this chapter.